In this video, I am going to talk about gravitational waves. This field has certainly made a mark in today's world. This year's Nobel for Physics went to three scientists who were involved in the detection of gravitational waves. Now we can see what you mean by gravitational waves. Introduction. That is, gravity is a force. It is a force just like the electromagnetic force or the nuclear force. In the case of this electromagnetic force, nuclear force, etc., we have identified particles that transmit the forces at a quantum level. In quantum theory, each particle acts as both a particle as well as a wave. Hence, it is quite natural that in the case of gravity also there are similar way in which force is transmitted. Now, what is gravitational wave? A gravitational wave is a concept which was predicted by the Einstein's general theory of relativity. The theory of general relativity states that a mass distorts both space and time in the same way a bowling ball will distort a trampoline. That is, a bowling ball is very heavy, and if it is kept on a trampoline, the trampoline goes downwards and it gets distorted. In the similar way, the space-time is also distorted by a massive object. When an object accelerates, it creates ripples in the space-time, just like the what causes ripples in a pond. These space-time ripples are the gravitational waves. Why is it really necessary that we observe these gravitational waves? It is necessary since gravitational waves are important in telling us about the early universe. Now, in this figure, we can see that the surface is distorted by a heavy ball. In this similar way, space is distorted by a heavy body accelerated through space. In this, we can see that the distance between 2 points are changed when the surface is distorted by this heavy ball. Now, how do we detect gravitational waves? Gravitational waves are extremely weak and hence it is hard to detect. That is why it took these many years for us to directly detect gravitational waves. It is extremely weak. As the strength of the wave depends on the mass of the object, our best hope of detecting gravitational waves comes from detecting two black holes or pulsars collapsing into each other. These are really massive objects in space. Now, how have we detected gravitational waves? That is, missions like LISA or LIGO hope to spot gravitational waves detecting small changes in distances between objects at set distances. And the changes in distances are found out in the case of LISA by using satellites, while in the case of LIGO, it is found out using mirrors. What do you mean by LIGO? LIGO stands for Laser Interferometer Gravitational Wave Observatory. This is a ground-based gravitational wave observatory, and it made history by detecting the first gravitational waves from the merger of two stellar mass black holes. The Laser Interferometer Gravitational Wave Observatory searches for distortions in space-time that would indicate the passage of gravitational waves. A laser beam is split down into two 2.5 arms containing mirrors, and the change in distance can be observed by the change in time observed in the traveling laser beam in these two hands. To date, LIGO has announced detection of a total of 3 black hole binary systems and 1 strong candidate system. The LIGO laboratory operates 2 detector sites, one near Hanford in eastern Washington and another near Livingston, Louisiana. Actually, the wavelength of these gravitational waves are in the order of hundreds to thousands of kilometers. Now LISA. LISA stands for Laser Interferometer Space Antenna. It is a European Space Agency mission. And this one is newer than the other project. LISA consists of 3 spacecraft that are separated by millions of miles and trailing tens of millions of miles. These 3 spacecraft rely on laser beams back and forth between the different spacecraft, and the signals are combined to search for gravitational wave signatures that come from distortions of space-time. As in the case of LIGO, here also the change in the laser beam's timing is considered to detect the change in distance. These are highly sensitive, and these 3 spacecraft actually form an equilateral triangle. Now the first detection of gravitational waves. It took place on 14th September 2015, and it was announced by the LIGO and Virgo collaborations on 11th February 2016. The waveform detected by both the LIGO observatories met the predictions of general relativity for a gravitational wave emanating from the inward spiral and merger of a pair of black holes of around 36 and 29 solar masses, that is, highly massive black holes. Rainer Weiss, Kip Thorne, and Barry Barish were awarded the Nobel Prize for detecting gravitational waves. Thus, that is the end of this video. I have talked about some basic concepts regarding gravitational waves, their detection challenges, how they are detected, etc. In case of any doubt, feel free to comment in the section below this video. Thank you.